Oh no, I do have strep throat, I just found out.
You have what? Strep throat?
Yeah.
That's no good. You got to make sure you take care of that.
Yeah.
I mean, make sure you take your antibiotics for the full 10 days.
Yeah, will do.
Yeah. Because that can lead to rheumatic heart fever if you don't take care of it.
Mm-hmm.
I know because I got it when I was 12, and that's exactly what they told me.
Really?
Yep. Yep. That's not something you want to mess with, strep throat. You definitely want to make sure you kill it the first time. So what are we doing tonight?
I want to look online if I have homework.
Okay.
I might not, but I'm going to check.
I had a wonderful experience on Monday morning. I woke up and my hard drive had crashed. It's unreadable and broken.
Oh, really?
That is one gigantic pain in the ass, let me tell you.
Yeah.
You have to completely start from scratch. It's taken me
Yeah.
two days to be able to get back to the point where I could even have online sessions.
March 1st.
Uh-huh.
Yeah, I don't have any homework.
Don't have any at all?
None.
What kind of stuff are you working on? What was the last stuff you covered?
Well, I can read some of the stuff up for a test that's coming up.
Okay. You got a test coming up?
Yeah.
And you have some review material for it?
A little bit, yeah.
Well, let's do those. That's the best way to prepare for tests, is to take the review material that the teacher gives you and just make sure you know how to do all those questions. That'll usually get you in pretty good shape for doing the test.
Yeah. I have this link to send you.
Okay.
Thanks a lot. I sent it in a chat thing. I didn't email it.
Ah. Does that mean I can... Okay. Yeah, that's actually a little quicker, isn't it? Yeah, cool. Okay. Yeah, let me... So this is your test material.
Yeah.
Let me look at it. Question 1 for a moment. I presume for question 1 they want you to use your calculator?
Actually, they do not. They want you to get it as close as possible.
Ah, okay, good. I actually like that a little bit better. So, let me put a moderate grid on here. And let's see, my scores go from 0 to 100. So we'll make that 100, we'll make that 50. That should do. Now, to draw a scatter plot of the data, where's the first point go? Give me the coordinates of it.
0, 52.
Okay, that's right there. I'm going to put X's for these points. Second point.
163.
Third point.
276.
Notice that it doesn't follow the table. Yeah. Oh, yes, it does. My apologies. 276 is correct. That's halfway. And then 382. And then 475. And then 594. All right. Notice that if I connected each of those x's with a line, it would not be a straight line.
Yeah.
The whole point is when you have points of data like this, you kind of feel like it's linear, right? In other words, however many hours you study should be reflected in your score in a linear fashion. In other words, by linear, it's going to go up. In other words, if you go from 1 to 2 hours, you'll get an incremental difference in your score to a point. So if I was trying to draw a line of best fit, I might draw a line between the first x and the last x. Straight line. Okay?
Yeah.
I could also draw that line maybe like this. So there's a few possibilities.
Yeah.
And the one advantage of using your calculator is that it will actually use an algorithm to determine the perfect line of best fit. And it uses it calculates it using a very complex equation that has to do with the distance of each x from the line measured perpendicularly, and then squaring each of those distances and adding them all up. And whichever produces the smallest sum, that's the line that they come up with. We will assume that this black line that I drew is that line. Now, write an equation of that line that fits this data and the way I've drawn it. First of all, what's the general format for the equation of a line?
Y equals MX plus B.
What's B in this case?
Slope.
B is the y-intercept.
Yeah, sorry about that.
What is the y-intercept? It's when x is 0, so it's 52. Okay? Remember what this graph looks like. It looks like this. So I'm looking at the y-intercept with that first x. Now I need the slope. If I can come up with the slope of that line, I'll have my answer. I'll substitute it for m, and we'll have the equation. Well, the best way to come up with the slope is the two furthest points apart. What's the rise? Slope is rise over run. Well, what's the rise between the x on the left and the x on the right? 94 minus 52.
Yeah.
So 94 minus 52. And what's the run?
5 minus 0.
Yeah. So that is 42 over 5. There's my slope. So now my equation is y equals 42 over 5x plus 52. The only point we know almost for sure is the 52, because it gave us a value when hours studied was 0. I love this problem. Every single algebra student gets this problem. You know why? Of course. They're promoting studying. In other words, what they're secretly trying to tell you is that if you study for 0 hours, you'll get a low score. If you study for 5 hours, you'll get a near perfect score. That's the subtle message that they're giving you. Okay? All right. C, interpret the slope and y-intercept of the line.
Kind of explain what they are.
Yeah, in other words, slope would be how much your score will improve per hour that you study. For every additional hour that you study, your score will go up by 42 divided by 5, which is like 8 2/5 points.
Yeah.
Notice that when we went from 0 to 1, we went up by 11. And then from 1 to 2, we went up by 13. But then from 2 to 3, we only went up by 6. So these points don't form a perfect straight line, and they never do. All of these problems it's always a scattering of points. And the key is to draw the perfect straight line through those points. Well, your calculator can do it, but we can also do it by estimating it like we did. And to get the slope, I use this point and this point. I could have used this point and this point, but notice that wouldn't have been as quite accurately. It wouldn't have been as accurate. That would have given me the slope between the first 2 points. That's it. If I want the general slope of this equation, I want those 2 points to be separated by as far as possible on the x-axis.
Yeah.
All right, just because it makes for a better interpretation. So, first of all, if we interpret the y-intercept of the line, that's what you score with no hours studying.
Yeah.
Okay? And the slope, well, that means for every hour that x goes up, your score is going to go up by 42 divided by 5, which is about 8 points. So that's the interpretation of slope. Now predict your test score if you study a total of 6 hours.
It'd be around 100%.
Well, let's come up with an exact number. How would you come up with the exact number?
How would I?
Yeah. In other words, here's our equation. There's the equation we're dealing with. It measures y being the test score you're going to get, x being the number of hours you're going to put in.
So I'm going to plug in the 6 for the year.
Yeah, so I got 42 over 5 times 6 plus 52.
Yeah.
You have your calculator handy?
Yes.
Come up with a number for me there.
42 divided by 6.
Divided by 5 plus 52.
50.4. It's 102.4.
Okay, so notice that the perfect score is 100.
Yeah.
So you can't really, in other words, what it's telling you is that you reach a point of diminishing returns, where the more hours you study doesn't necessarily add 8 points to every test score.
Yeah.
So in our line, or in our equation, hold on. God, what the heck? Oh, okay, here we go. The real line wouldn't be a straight line forever. It might look like this. In other words, it might go up linearly until you hit 5 hours.
Yeah.
But then after that, it's incremental increases.
Yeah.
So you'd have a bent line.
Okay.
Because as you add more hours, you don't necessarily, you might pick up 2 more points by putting in a 6th hour, and another 2 points by putting in a 7th hour. In other words, your slope decreases after a certain number of hours. You're not going to go down. In other words, if you put in 10 hours of study, you're not going to get less than a 94, but you certainly aren't going to score 120. In other words, 100 being the maximum, so you know this thing can't be linear forever. It's got to flatten out at some point. The correlation coefficient for this data is 0.919. Let's talk about correlation coefficients.
not even know what that means actually.
Well, if you put this list, two lists into your calculator, and you let your calculator calculate the linear regression, it will not only give you the equation, it'll tell you M and B, but it also will give you something called an R, the correlation coefficient.
Okay.
And here's what that means. If I have a bunch of points that look like this, and I try to draw a straight line between those, wow, those points are in a straight line.
Yeah.
That's a high correlation coefficient of 1. If I have similar, only the points aren't quite in a straight line, but clearly they go in a straight line, that might have an R of 0.9. Notice why the top one has a higher R than the bottom one. There's no deviation in the top one at all. If you drew a line between every single point, you'd have a straight line. Whereas the bottom line, I got to approximate a line through the scatter plot, which means my correlation coefficient isn't as strong. A perfect correlation coefficient is 1.
Yeah.
A non-perfect one would be like 0.919. 0 would be, if I had a dot there, and 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 a dot there, well, I can't see any straight line at all there. I could draw a straight line through it, but my R is going to be very close to 0, might be 0.1. Because those dots don't look like a straight line very much. They don't even, you're not going to get a high R. So an R is pretty much the measurement of how far each dot is away from the line and add them all up. In other words, I've got that distance, I got that distance, I got that distance, I got that distance, and so forth and so on. I've drawn a straight line amongst those dots, but the dots don't particularly lend themselves to a straight line. So I don't have a high correlation coefficient at all.
Yeah.
0.919 is relatively high. And what that means for your data is that, yeah, these are linearly related. Linear being straight line. In other words, there's lots of different ways I can have dots like this.
Yeah.
That's not going to be a linear. That looks far more like parabolic to me. So if I wanted the equation that put these dots together, I would do a quadratic regression on my calculator. I'd put the dots in as two different lists, and depending on the question, they'll tell you whether you should do a linear regression or a quadratic regression or a square root regression or a sinusoid regression. There's all kinds of different ways to put this scattergram of dots together. And it just depends on what they ask for. All right, number 2. Oh, Jesus. Another box and whiskers. So you tell me how to do this. You knew how to do box and whiskers last time. I did not. Do you still know how to do it?
Yeah.
Okay, good. Here, let me repeat the line, and you tell me how to put a box and whiskers thing on this thing.
Well, first you gotta arrange the numbers so that they're in order.
Okay, they are.
So we're gonna have 0.
Oh, no, they're not. Okay, sorry. So 0, 3, 3, 7, 14, 9,
Yeah,
14, 21, and 24.
Yeah.
All right, now what's the next thing we do?
We need to find the median, which is going to be 8.
Okay, so 8's the median.
We're going to put a marker there over the 8.
On the graph also, like that?
Yeah.
Okay.
We need to find the upper quartile and the lower quartile.
Okay, so the first quartile would be 0 to 4.
Yes.
The second quartile would be 4 to 8, right?
Actually, we need to find the, what was it?
I think you're right. It's been so long since I've done box and whiskers plot. Like I said, you don't ever get these again, unless you take a statistics class.
I think the lower quartile was 3.
Because the lower quartile is that point right there. Okay, so I put a point at 3, and then I draw, let me see if I can figure out how to do this. So is it like that?
Yeah.
Exactly like that?
The 8 is just going to reach the 4, and it's not going to, it's just going to reach to the 3, and that'll be it.
Oh, yeah, I didn't draw it right. Okay. So the box goes around the second quartile?
There's 3 quartiles. There's going to be 3, 8, and then 17.5 is the third one.
Okay. So, all right, maybe we can do the box and whiskers after we answer the next 3 questions, because I think that'll help me understand it. So what's the range?
The range is going to be 17.5.
Hold on. What's the range of this data? Range is the low to the high.
24, I think.
Right. 24 minus 0 is the range.
Yes.
Okay. The interquartile range.
That's 14.5.
That's what?
14.5.
How do you get that?
The quartile 3 minus quartile 1, which is 17.5 minus 3.
Okay. So that's the difference between the, in other words, when I break this up, I've got a point here at 9. I got a point here at 3.
Yeah.
And then the midpoint of this is
17.5.
17.5.
Yeah.
So that's my first quartile, that's my second quartile, third quartile, fourth quartile, right? In other words, the first quartile would go from 0 to 3.
No, there's only going to be 3 quartiles. 3, 9, 17.5. Those are the 3 quartiles.
Well, those are the marking points, but quartile itself indicates fourths. That's what quartile means. So when you're dividing up data into quartiles, there's always 4 quartiles. But notice that the 4 quartiles, I only need 3 numbers to measure them. In other words, I've got a quartile from 0 to 3, there's 1. I got another one from 3 to 9, that's the second one. Got another one from 9 to 17.5, that's the third one. And finally, the fourth one goes from 17.5 to 24. So those are your 4 quartiles. That's 1, 2, 3, and 4. So I'm not quite sure what it wants. When it says the interquartile range, you're saying from the end of the first one to the beginning of the fourth one. And that's how you get 14.5, okay?
Yeah, that's how I did in class.
How do you determine outliers? There's a formula for that, if I remember right.
Maybe.
Yeah. Hold on. Let me open my book. Wow, I got to go to my precalculus book. My Algebra 2 book does not have this in it. But my pre-calc book does. You know, it's kind of brutal, actually, that they teach it this way. All right, let's see. Statistics. Let's see. Okay, so the interquartile range is quartile 3 minus quarter 1. And you're right, there's a what's called a 5-number summary. And that's actually 5 points. In other words, the 5-number summary here would be 0, that point, and let me in green. If I'm doing the 5 quartile summary, there's the left part of the first quartile, there's the second number, there's the third number, there's the fourth number, there's the fifth number. There's always 5 numbers in a quartile summary because you need the beginning and end of each of the 4 quarters. Okay. Now, they do have a formula for outliers. Defining outliers. It must be a point, it must be, the rule of thumb given here for identifying outliers is not universal. In other words, it's not, if you went to Russia, they wouldn't necessarily give you the same answer. The only sure way to characterize an outlier is if it lies outside the expected range of the data, and that expected range can be a judgment call.
Yeah.
Well, I've seen a formula for it. What have they told you in class? Have they given you a formula for identifying outliers?
No.
Here's the formula. It's Q3 plus 1.5 times the interquartile range. So that's what we want, is we want to do Q3 plus 1.5 times IQR. Well, Q3 is,
17.5.
so we got 17.5 plus 1.5 times IQR. And the interquartile range was 14.5. So any outliers that are beyond that. Let's see, that looks like 17.5 plus, if I add 7 1/4 to that, it's 21.25. So any point that's greater than 38.75 would be considered an outlier. At least that's the formula that's in my pre-calc book. I don't know if they taught it to you, and my book admits that it's a judgment thing. In other words, this formula right here to determine whether something's an outlier is not universal. That's strictly a judgment call. But in this case, since our highest point is 24, we don't seem to have any outliers. No, I don't know how they treat the lower end of that.
I don't.
Would it be Q2 or Q3 minus 1.5 times the interquartile range?
I think it's probably quartile 1.
Yeah, I don't know. I don't know. My book, My book does not address it. So let's not get hung up on it. For one thing, it's not a universal mathematical thing at all.
Yeah.
Whereas interquartile range is.
Yeah.
That's definitely your third quartile endpoint, right-hand endpoint, minus the first quartile right-hand endpoint. Okay? All right. Let's see. Well, I don't know that this requires very much statistics. Is your friend's claim correct?
No. It isn't correct.
Because?
Because the girls have a...
First of all, what percentage of males have Instagram accounts?
Hold on, let me get this real quick.
Well, give it to me as a ratio. 53 divided by what?
83.
Okay. And females is what? Females is 48 divided by 70. So whichever one of those gives you a higher percentage, females does?
Yeah. There's is 0.69 and that is 0.64.
Okay, so females are the higher percentage.
Yes.
Okay, we've answered A. Rather than using a two-way table, what's a better way to present the data? I actually know this.
I do not know.
Yeah, here's a better way. Let me suggest this way. And that's to put totals and do everything as a percentage. In other words, here's what I'm talking about. First of all, let me do this. Words, here's male, female, yes, no. But if I had another line that said total, that would be helpful. And along the bottom also, where it says total.
Okay.
And we know that there were a total of 83 males, so our table now looks like this.
Okay.
And that even tells us the total is 153 people. The total without Instagram accounts is 52. The total with Instagram accounts is 101.
Yeah.
Now it's a little easier to figure out percentages because we don't have to do any math. We're just going to take 53 divided by 83. And we're going to take 48 divided by 70. So there's another method that's called a, what's the word? Where instead of in the box, instead of listing absolute numbers, you said that that was 0.64, right?
Yeah.
Well, that makes this one 0.36. And you said the females was 0.69, which makes this one 0.31. So this table here would actually be superior if I did everything in percentages. And there's a word for this, and I can't remember exactly what it is, but the percentages add up to 1. So this is 100% of the females, that's 100% of the males. So this plus this has to add to 1. This plus that has to add to 1. But you can see the advantage of having the table that just has the decimals in it, is that you don't have to do any calculations to figure out whether males have a higher percent of Instagram or not. You're looking at it. There's the highest percent right there. Females who have Instagram accounts, 69%. There's a word for this kind of table. Oh, God, hold on. I don't want to spend a lot of time on my lack of knowledge on this stuff. But the funny thing is, none of my books actually do this. Only time I've ever seen this is in students' problems. I cannot remember the word that I'm looking for. Hold on, maybe this has it. It's not percentage, but it's like percentage. Frequency. This is called a frequency table. Because what it's showing is the frequency of males that have Instagram accounts. We don't care if it's 53 males, but it's very important that 64% have Instagram accounts. So a frequency table gives you actually more information than a straight out table does. So the answer is frequency table to 3B. So that's what a box and whiskers plot is. In other words, can you see my cursor?
Yeah.
Okay. So that is the right point for the first quartile. Am I correct?
Yes.
And that is the right point for the third quartile.
Yes.
And the bar in the middle must be the right point for the second quartile. Okay. Now I understand. I don't think you're going to have any problems with this, are you?
No, I feel pretty confident in it.
Yeah, you're going to align the numbers up from smallest to biggest, and then you're going to find your 5 key points. Remember, there are 5, because in other words, you're going to have the beginning of your first quartile, the end of your first quartile, the end of the second, the end of the third, and the end of the fourth. So you always have 5 points. And in your box and whiskers plot, whoops, it doesn't go to the fourth, it goes to the third. With that would be my box and whiskers plot right there. Wow. All right, so I don't feel like we need to go over 4. How come this one goes Arvada West and this one is Ralston Valley?
It's kind of confusing.
Yeah, in other words, they didn't ask any questions at all about the Ralston Valley. Am I correct? The box and whiskers plot that they show you is for the Arvada West times.
Yeah. No, you use it for part A to create the histogram.
What's that?
So you use Ralston Valley for part A, and for part B you use A West.
Well, let's talk about histograms.
Yeah. They're like bar graphs, basically.
What's the horizontal axis in histograms? Is it times or number of competitors? It's times. And it's split up. In other words, what's the low number there? Is it 423?
Yes.
All right, so let's go from 423 to 523. I don't think this much matters. And count up the number of, this is the number of runners that fit into that category. Okay, well, between 423 and 523, I see 1, 2, 3, 4, 5, 6. So there's 6 people.
Yeah.
So that would go up to 6. And then I would go from 523 maybe to 623. And how many people are in that? 1, 2, 3, 4, 5, 6, 7.
Yeah.
I think. It doesn't matter if I counted wrong or right. The point is how you do these. And I'm going to go all the way through. Now, maybe each one of these should be divided up by the quartiles. In other words, this should be the first quartile, maybe. And that's the second quartile. So that's first quartile, second, and so forth. So you'd end up with 3 bars, maybe that look like that, or 4 bars, one for each quartile. I'm not sure if that's the way they do it. And I don't think there is an accepted way to do that. There's just, you break up the horizontal axis into time increments, and you count how many people ran it in between those 2 times. And that's what goes on the vertical axis. And this kind of, if this were accurate, that would be instructive looking at a chart of it. That means the majority of people ran between 723 and 823. In other words, slow runners. If I compared the histogram for Ralston Valley with the histogram for Arvada West, I might be able to notice certain things. Like which school has the best runners for this obstacle course. It's hard to tell from the raw data, but it's a little easier to tell from the box and whiskers plot, if I had box and whiskers for both. And it's a lot easier to tell if I had a histogram for both, especially if the time scale was the same for both. And I don't know that it has to go from 423 to 523. Maybe it goes from 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, and so forth. Either one is going to give you a picture image of, in other words, what we're always trying to do with statistics is take a bunch of numbers and try to draw some conclusion from it. In other words, if they gave us the Ralston Valley obstacle course times and they had another table that was exactly the same, only Arvada West, it wouldn't be that easy to compare which one was the faster people, which was the faster school, right?
Yeah.
But if you had box and whiskers, you can make a better judgment of it. And if you have histogram, you can make a better judgment still. So that's the purpose of these box and whiskers and histograms, is it gives you a way of graphically looking at a bunch of data points, which are hard to analyze statistically in your head. There's just too many data points. In reality, you might have 100 data points, not just 20. And then it would be really tough. So we know how to create the histogram for Ralston Valley, or at least we know approximately how to create it. I'm not 100% sure how we're supposed to label the left and right side of each bar that I've done here.
Yeah.
But presumably your teacher will let you know that.
Yeah.
Well, the nice thing is that if we know the median of each, well, we certainly know the median of Arvada West, right? What's the median of Arvada West?
Arvada West median is 6.5.
Yeah. And then if we line up all these numbers in order, we could figure out the median of this.
Yeah.
So if we do a little more work, or if we had box and whiskers for both, we'd be able to answer part B1.
Yeah.
Okay. And, oh, I see, this is a multiple choice. Yeah. Skewed left means the following. If my histogram looks like this, it's called a normal distribution. If it looks like this, that would be skewed left.
Yeah.
If it looks like this, that would be skewed right, the green. In other words, if you have a predominance of numbers to the right of the middle, it's skewed right. If you have a predominance of numbers to the left of the middle, it's skewed left. In actuality, if you were to take all 320 million people in the United States and draw a histogram of their heights, it almost is always going to have a normal distribution. In other words, this might be 5'10" and on the short side over here you might have some men, let's say men only, that are 4'9", and over here you might have some men that are 6'10". But in general, you're going to have a very normal distribution curve on most data, whether you're looking at heights or weights or anything. Most data is normally distributed. And you might have some outliers over here where you have some basketball player that's 7'10". Well, how many of those are you going to have out of a population of 300 million? Not very many. And so by most any definition, that would be an outlier. And maybe you'll have a midget over here that's 4'2". He's an outlier also. And again, the outlier, you can come up with a formula that tells you the outlier. The one in my book is the first quartile plus 1.5 times the interquartile range. Anything that's outside of that is an outlier. So, which statements are true? Well, without doing a lot more work, we can't really answer that. We have to either, the best thing to do to answer part B would be to draw a box and whiskers for the Ralston Valley obstacle course. And then that's going to let us answer all four of these questions. Well, it might not answer whether there's an outlier or not. It could be. Notice the Arvada West has somebody ran it in 9 minutes. And nobody from Ralston Valley was higher than 8 minutes and 4 seconds. So that 9-minute time could very well be an outlier for Arvada West. Their 5-minute time certainly is not an outlier. We got a lot of people in Ralston Valley that ran it under 5 minutes. I mean, just by looking at the data from Ralston Valley and Arvada, Ralston Valley clearly is the betting favorite. I mean, they got 1, 2, 3 guys that broke 5 minutes, whereas Arvada West got nobody that broke 5 minutes. Plus, Arvada West has at least one person that did 9 minutes, whereas Ralston Valley, their highest runner, did it in 8 minutes. So Ralston Valley is certainly a better track team, or whatever, than Arvada West, according to this data. Whether it's skewed left or not, I don't know if you can tell that from a box and whiskers. You can certainly tell it from a histogram. You can probably tell it from a box and whiskers. I would say that Arvada West is skewed to the right. They have more times to the right of that median than they do to the left, I believe. But I'm not positive about that. I know that if you had a histogram, you could certainly tell whether it was skewed left or not. And if you had box and whiskers on both, you could answer 2 or 3 of those questions at the bottom. All right, so I probably learned as much about statistics as you did today.
Yeah.
But nonetheless, you do appear to have a pretty good grasp on statistics. Just remember that there are 4 quartiles, not 3.
Yeah.
There's 3 points that mark the key points, but there's actually 5 points that make up 4 quartiles, because you have to have the left side of the first quartile and the right side of the 4th quartile. So there's actually always 5 key points. Okay?
Yep.
All right. God, I hope you're done with statistics soon.
I hope so too.
Why? You do great in statistics. You understand statistics well, it appears to me.
Yeah, they're just pretty boring.
Well, believe it or not, statistics are actually a very valuable science. I'm almost sorry that I don't tutor it. Just because so much of the world requires statistics to figure it out. There's no formulas that people give you. But if you have enough statistics, you can answer a lot of questions like, which is the better track team, Ralston Valley or Arvada West? It requires statistics to be able to answer that question. All right, Nick, I will let you go and talk to you next Wednesday.
All right, sounds good.
All right, bye-bye.